integration for TC.
You did what?
We didn't do integration for TC, like we haven't started yet.
All right. So, yeah, when we come to integration, right, for sure we've all understood derivatives. We've understood the types of derivatives which you have. I think it's the power rule. So I can just specify. Let me do this. Okay, let me turn off. I want them to take a speaker, so I'm looking at it. I borrowed these guys my speakers, they're not making noise. Great class, boy. This pen is misbehaving. Yes. Let me try to connect this mouse and disconnect it again, because I had connected the mouse and then I think now it's giving me problems. Yeah. I think now it will be fine. Yeah, so when we come to the indefinite integrals, so we have indefinite integrals and definite integrals. So the indefinite integrals are the ones that we have the integrals without any values here, you see, right? So these are the first ones which you're going to be looking at. And I'll say that first, we're going to be focusing on reversing. You see, they say that this is the reversal process of differentiation. We can focus on reversing power rule. We focus on reversing power. You remember when I apply power rule, right? We say that if I'm given x to the n, what I need to do first is multiply. You see, what I do first is what? Multiply by this. So it's like I'm going this side. I'm multiplying by that exponent. Then I subtract 1 on the exponent. You see, right? Then I subtracted. The next thing which I did is subtract. Now, when I have to reverse this, I'm going back, but I'm applying the opposite. You know, the opposite of subtraction is addition. And this subtraction was happening on the exponent. Now, the opposite of multiplication is division. So it means that now, for me to apply the reverse of power rule, now I must do what? I must take this nx to the n minus 1. I now add. You see, first thing I do is add. I add 1. Remember, when you were subtracting 1. So now I do what? I add 1. I add 1. You see, after adding 1, I divide by that exponent. You see, and then this will go and this will cancel. This will cancel. So I'll be left with x to the n. You see, now I took it back. So if you're given x to the n, for you to apply the reversal of power rule, you're going to add 1 and divide by that whole exponent. You see, so this is the idea behind the reversing the power rule. You'll see when we go to the examples and exercises. So first, with the one which is more simple to look at is power rule. We have things like sum rule, difference rule. Those ones are nothing. They just rules that we know that if I have the derivative, let's say I have the derivative of x plus 2. Here I just apply some rules. Some rules is that I'm just gonna be distributing this, right? So there's nothing that changes when it comes to sum rule, difference rule. Nothing changes. If I'm also gonna be having the integral of x plus 2 dx, I'm still gonna do the same thing. I'm just gonna distribute. You see, right? Nothing when it comes to those things of sum rule, difference rule. Nothing changes. They are all the same. They're just mere rules that are gonna help us to solve these in a simpler way. So now let me cancel this. Then we jump start and go to there. So let's look here. They say that if g is a function such that d so means that the derivative of g with respect to x is equal to f of x, then they say that g is said to be an antiderivative of f of x. So now they say thus an antiderivative of f of x is nothing more than a function g which when derivated it gives f of x. Then the process of determining g from f of x is called antiderivative. So if we're given f of x and then they say find g, you see. So let me write this for you in a simpler way. What do they mean about about this statement, this whole statement? What they mean is this. If I come here, I want to find g, right? What I'm gonna do, right? I'm just gonna introduce this integral, introduce integral this side, introduce dx, introduce dx this side. This dx will cancel this one, you see, right? And then this d will take care of what? Of the integral, but they need to leave us with plus c. You see, right? So I'm gonna have g plus c. This will be equal to the integral of f of x dx. So you see, every time after integrating this, we must, whatever we get, we must add c always. So that's what the statement is saying there. If I try to break it down, so now, yeah, then let's come down to this definition. I think this is just what I explained, right? Then they can also say that you multiply both sides by dx. This is why they got this. Then now let's come to this. Then we are given, they say that f of x is equal to x squared. Then the derivative of x, this they say d over dx of that g. So here they just integrated, right? Is equal to x squared. So in other words, right, if I'm integrating this, if I want to integrate x squared dx, what I'm gonna get is I take this and add 1 on the exponent, take that whole exponent, put it on the denominator. You see, right? Then this will be what? X to the third over 3. This is g there. You see, right? Then I would get that. But this is not what we're focusing on now. So here they're just explaining to us what does this mean, given that they're talking about that definition there. So it won't contribute that much. So now when we come to this function, there's this function that when this one of 1 over x, that when I try to integrate 1 over x, when I try to integrate anything of 1 over, you see, right, as long as it's 1 over x to the something, this first I must change it to this. I must change it to this dx. Remember, when I apply the antiderivative of power rule, This says that I'm going to have what? Says that I'm going to have minus 1 plus 1. I take that minus 1 plus 1 to the denominator. Then this would be what? X to the 0 over 0. Now the numerator would be fine. We would get 1. But the denominator is 0. You see that this one gives us some error, right? Then if that is the case, now you opt for lean. Lean is like a second choice. Or not just a second choice, second option. Like you have no choice. You have to take it. You see that? And then if that is the case, then you can have this as ln of x. You see, right? Then you have that. So that will be the case. Remember this. When I derive ln x, what do I get? 1 over x times the derivative of what? Of the inside. You see, right? But when I'm going to integrate this, check, when I integrate this, it's like here, it's like deriving 2x. You see, I'm going to get ln of 2x times, let me say 2x squared, ln of 2x squared times the derivative of 2x squared. Let me cancel this and put it. I want to show you some rule that they usually won't discuss it, but you're gonna have to use it. So if I come here and differentiate ln over 2x squared, this I'm going to get 1 over 2x squared times the derivative of 2x squared. You see, this would be 4x over 2x squared. You see, right? And this would be what? This would be 2 over x. Now check. When I'm going to integrate this to 2 over, I want to show you something. When I'm going to integrate this 2 over this, right? First, I must take out, obviously, the 2 outside. You agree, right? Let's take it out. The question is, can I be able to go back to the original question? Can I? Anyone who can agree or disagree, can I be able to go back to this? Now I must take this, go back here. Which these are the type of questions that we're going to be discussing in most cases, right? They may try to trick you on such questions. Can you try to go back there? The question is, can you go back? Now let's check if we can go back. Can we go back? And I thought maybe someone wanted to say something. So check this. Check this. You have ln of 2x squared, right? Ln over 2x squared is what? Is 2 ln of 2x. You see, right? And this will be 2 ln of 2 plus 2 ln of x. So now what I'm going to have here is 2 ln of what? Of x plus c. Check this. That's why I must add plus c. When I add this c, now I must find c. Check, you see? When I add c, that will be our c. So the question is, how do I find c? You see what I got here? From this only, I got this. Then that plus c, you see, that's why we need plus c. So usually we stop here and say plus c. Unless if you have to find the whole thing. They were saying that this can be any constant. And the constant there is what? There's 2 ln 2. Likely you guys, they don't ask you to take this back to the original one. You just have to integrate. You get whatever you get, you add c. So if you forget c, your solution is wrong. So this is what I'm trying to show you. You see that this whole thing is what? Is 2 ln 2 plus 2 ln x. So if you forget plus c, you're dead. You see, right? So yeah, don't forget plus c. Yeah, now I think we can go to the examples and see. So you never forget plus c. You forget plus c, the solution is wrong. Let me see. Now you see, must always have plus C plus C. And also our ln, you see, right, your ln will always be here. They're also showing you. So your ln, every time after integrating, you're going to have the absolute values instead of having, you see, right? So we'll always opt for this one. We'll see that when we're doing more examples and differentiate when can I use the one of ln of this and when can I use the ln of this one. You'll see that. And then let me see, I want to check those that, yeah, so these are the rules that we're gonna be focusing on. So explaining the first rule, right? Here we are if we are integrating a constant only, right? If we are integrating a constant only, first, if I'm integrating a constant only, let's say I'm having the integral of 2 dx. What I'm gonna do first, I'm gonna take out 2, I integrate. If I have nothing there, guys, any function goes with 1. It's that function times 1. And what is 1 in this case? X to the 0. You see, right? And this will be what? Using that rule, x to the 0 plus 1 over 0 plus 1. You see, right? 0 plus 1. Then I add my c. And this will be what? 2x plus c. That's why here we got kx plus c. So in this case, our k is 2. You see, when you're deriving a constant, that's what you get. Then if I'm deriving just any function with n being 1 or any number that is greater than 1, it's either equal or greater than 1. So here it's like when n is 0. Here it's when n is greater than 1. So now when n is greater than 1, we're just gonna do this. We say x we add 1 on the exponent, then we take that exponent, we divide by 8. You're gonna see when we do more examples on this. So we're gonna, almost every question we're gonna do, most questions that come here, they require this. Then integrating e to the x. You remember when we derive e to the x? When we derive e to the x, let me create a page and show you this. When we derive e to the x, remember, we say we write e to the x times ln e, which is the ln base, times the derivative of what? Of the exponent. You remember, right? Which this would be e to the x times 1, which is e to the x. Now, when you come to integrate e to the x dx, remember you keep this first. What did you do here? You multiply it. That means that here you're gonna do what? Divide by that whole thing which you multiply. Divide by ln base, divide by the derivative of exponent. It's right. You divide by this whole thing. This goes together, it goes together. You see, right? So all that. You see, right? So that's how we apply e to the x. That's why e to the x will always remain e to the x, whether you integrate it or you derive it. Then plus c. The only difference is that when you integrate it, when you integrate it, you add c. You see, right? That's the only difference. And then when we come to this one of ln x, this one of ln x plus c, I think I've discussed this. For the time being, we can skip it. And then this one, if I'm given the integral of 2x dx, the up there I showed you of 2 alone, right? Then this, I'm going to take out a constant. I take out a constant, I'm left with this. Remember from limit laws, right? You were doing something like this. You were taking out a constant, you apply the limit of a variable. This will be 2x 1 plus 1 over 1 plus 1. So this will be x squared plus c, because that denominator of the 2 will cancel out the 2 here. This 2 will cancel out this 2. So we're left with what? 2x plus c. We're left with x squared plus c. So we see, right? Then that is the case. And then this is the one I was telling about, that if there's some rule or difference, we just distribute. Nothing changed there. We just distribute. So these ones, we'll talk more about them when we are doing the derivatives integrations. So if you look at the first example, we have the integral of 3 over 4 dx, which our k is what is 3 over 4. You just have to take out the constant. So this is the same thing as having 3 over 4, the integral of x to the 0 dx, which this will be equal to 3 over 4 x to the 0 plus 1 over 0 plus 1 plus c, which this will be 3 over 4 x plus c. You see, right? Then that is how you apply that one. So let's see on this one. This one is the one of the exponent, you see. So the exponent, it's simple. Here you're just going to have to come and say this will be x to the 5 plus 1. You take that whole exponent, you divide by 8. So I don't think I have to write this one. You add your c, then that will be x to the 6 over 6 plus c. So always your exponent and denominator should be the same, unless if this thing had a constant. But if it didn't have a constant, exponent and the denominator should be the same to confirm if you're correct. Unless if it was like this, you see this one have an exponent. So if we do that, you see even here, check this. If I do this alone, I get what? X to the 4. You see, right? The exponent and the denominator are the same to confirm that we are writing the correct thing. Then if I come and plug it here, you remember I write the constant. So 8 divided by 4 is 2. That's why I got this. And this also multiplied with the what? The constant. So this constant, when it goes outside, I integrate this, it's always going to multiply the constant. So we'll discuss this more. So we'll discuss this. Yeah. But usually with us, there's no need for us to say C1, but we'll do that. We'll just do that. Don't worry. You see, even here, they say that it is not necessary to write all the intermediate steps in the integration process. Concisely, we have this, which will be equal to this. So there's no need for us to write this. Those who are doing applied maths, for sure, you know, for this, yeah, for you guys, I think it's important. But if you're not doing applied maths, it's not. So on SMTH, it's not that important. Then here we can just take out the constant. We take this out constant. We integrate e to the x. We know that e to the x will always remain the same. So this will always be the outcome. You see, right? Then if you have a question like this, you remember even when you integrate, even when you derive this, you first change this root of y. You see, you must put it in this format first. Even when you integrate, you must put it in that format. So the question is, when can I change this to ln? You don't just come here and say, someone I know would come and say ln of root of y. That is incorrect. How do you check? Does ln accommodate this question? First, you must come and take this, add 1, also on the denominator. If you get 0 on the exponent and 0 here, then you know if I get 0, 0, I know now I can use ln. You see, just ask yourself in your mind, if I have this, I add 1, you do the calculator, will I get 0? If not, then you can't use ln. You only use ln if you get 0. You see, right? So now when you come to this one, you just apply your sum rules. You distribute like this, you see. Distribute separately. Then when you distribute it, now you can apply your limit laws. This one, you just have to add the 1 there, also the denominator. You see, the numerator, the exponent and denominator are the same. So you confirm that you did the correct thing. Here you have the 2 outside as a constant. The 2 plus 1, exponent and denominator are the same. You see, right? So usually, let's not use this first approach. Remember we say that this is not that important to look at it. So let me highlight the one that we're going to be focusing on. Is this one. So instead of saying C1, C2, I'm just gonna, from here, I'm just gonna highlight steps that you must apply. You see right now, highlight here. This one is important. This one is important. This is important. When you come here, you're just gonna say plus C. Let's erase this. You see, you're just gonna come and say plus C there. Then I also erase this. I think this and this are the same. You see, you're just gonna say this. So let me just write this on a new page. Then you see how I want you to write it. So these are okay. Let me write it here. So from this part here, we can just come and say x to the 3 plus 1 over 3 plus 1 plus 2 x2 plus 1 over 2 plus 1 minus 4x plus c. You see, right? So this, you see, from here it goes here. You see, right? From here to here you skip these minor steps. You remember what they said here? It is not that important to write those minor steps. So you move from there to here. You see how we're gonna be writing this. Then when you come to these ones first, also, you remember, before you can derive these, you must put them in this format. So that's what you should always do. You put it in that format. Also, these ones, you distribute using your sum rule and difference rule. You distribute your integral signs. And then you now apply your power rule, anti-power rule. When you derive e to the x, you know it remains the same. When you derive a constant alone, it's just gonna have x. You see that? These are like, if you realize, if you check this, these are one of the simplest methods you can come across. So far from the beginning, these are the simplest. Also, if you come to this one, what you have to do first is change this to x to the that. And then what they did here, they just separated this. You know that you know this 6x, this would be equals to cubic root of 6 times cubic root of x. You see, right? And this will be cubic root of 6 times x to the 1 over 3. Then this is a constant, I can take it out. You see, they took it out and integrated this one. So you see what they got there, right? Then that was the case. Then when you come to this one you have to cross multiply them first. You see, right? You cross multiply this, cross multiply this. Then you get this. You take out the 1 over 6. You see, the denominator says what? 6. You take out the 1 over 6. After taking out the 1 over 6, what happens is now you apply the sum rule here, while you keep the bigger bracket to show that this 1 over 6 will cover everything. You see, right? You'll see on the, I'm sure they did that on the next page. You see, right? Keep the big bracket to show that it covers everything. You see, they no longer do those things of C1, C2, C3, because they told you it's not important to do those things. You just need only one C plus C. You see, right? You see this, you just do them the same way. Exponent and denominator should be the same to show that you did the correct thing. Exponent, denominator should be the same. So you see this. So the reason why I'm skipping this, I'm just explaining this. You're gonna do them in class. So we're just gonna go to the exercises. So when we come to the exercises, number 1 says that we're given the integral of x to the third plus 4x squared minus 3 dx. So what happens here is this. Now let me copy this, then we write this. So what you're gonna do first, we're gonna distribute this. You see, right? When we distribute this, now we apply the antiderivative. You see, right? Then this is 3x plus c. Because this is a constant rows alone, so you're just gonna multiply by x. So this will be x to the 4 over 4 plus 4x to the 3 over 3 to show that, you see, the exponent and denominator are always the same, to show that I'm doing the correct thing. You see, right? And this will be the final solution for the first one. So if I come to the second one, I'm given the integral of 3 over x to the third minus 5x dx. Now, so first thing I do is distribute. And then I can take out this constant, set out this. Now this is minus 3. Then now I can integrate. Now it's plus 1. I take that whole denominator, divide by it. Add the c. You see, right? We are not supposed to forget the c. Then this is the same thing as having yeah, and that will be the solution to that. So now what we can do is let's look at number 3. The integral of 3x to the 3 over 4 minus 4x to the minus 1 over 3 dx. And now I copy this and paste. Then if we check here, still gonna do the same thing. We distribute Can someone check there what is 3 over 4 plus 1 while I'm still adding here? Someone can check that, and also someone checks this one. What is 3 over 4 plus 1?
7 over 4.
And 7 over 4. Then the other one. The other one is what?
Three over 2.
Is it 3 over 2 or 2 over 3?
2 over 3.
Yeah, and then this would be 3 4x 7 over 4 over 7 4 then that will be the solution, right? And then that will be number 3. So I'm sure if you look at it, just realize that I was just doing some calculations there. It doesn't matter how you do it, the aim is to get to the solution. So yeah, then we come to this one. We have minus 3 over 2 minus x to the 1 over 3 minus 2 dx. So what I'm gonna first do here is cross multiply. So I first need to multiply this. Not cross multiply, but yeah, I'm just gonna multiply this through. So first must have x minus 3. Is it 3 over 2? Yeah, minus 3 over 2 times x to the 1 over 2 to x minus 3 over 2 minus x times x to the 1 over 3 plus 2x dx. And then the first one, I keep it the base and add the exponents. What is minus 3 over 2 plus 1 over 2? That will be minus 2 over 2, which is minus 1, right? Isn't it so? Would this give us minus 1? Would it give us minus 1? Then 1 over this one, I keep the base and add the exponents. So this will just be 1 plus 1 over 3, which that will be 4 over 3, right? Then from there I can just distribute. So this obviously would be ln of x minus 2 x minus 3 over 2 plus 1. What is this? And also, what is this? What is the first one?
Negative 1 over 2.
It's a negative 1 over 2, right? And then this one, is it 7 over 4? No, 7 over 3?
7 over 3.
Then the 2 will cancel the 2 there. Then we'll have ln of x. The 2 here will cancel the 2. This becomes positive. X to the minus 1 over 2. Then this will be minus 3x to the 7 over 3 over 7. So remember, this one always goes here, right? Or you can just multiply here by 3 over 3. You see, right? And then that will cancel. Plus x squared plus c. Then this will be the final solution. If you want, you can also change this. It will become 1 over root of x if you want. So yeah, or it can become 1 over x to the 1 over 2, and this is the root of x. So likewise, it's gonna be the same thing. So are we fine? So I believe that doing these ones, now we all know how to do them, right? Now we all know how to do those. The idea was here, you need to cross multiply. So now another question that we have is this one. Now we're given the integral of 4 minus root of x squared dx, and then this is the same thing. You see, right? This is the same thing. So you just have to expand it like that. And this gives us 4 times 4 is 16. And then this minus this minus 4 root x minus 4 root x plus x dx. You see, right? So the root of x cancels out. So the root cancels out when you multiply those. And this will be the integral of 16 dx minus this will give us minus 8 minus the integral of 8 root of x dx plus the integral of x dx. And then this would give us, we know that the integral of 16 is 16x, and the integral of that minus 8 is x to the 1 over 2 plus 1 over 1 over 2 plus 1. Then the other one is plus x squared over 2 plus c. And this would be 16x minus 8x to the 3 over 2 over 3 over 2. C, right? Plus x squared over 2 plus c. This would be 16x minus, so this will be minus 16x 3 over 2 over 3 plus x squared over 2. If you plug your calculator there, check what is 8 over 3 over 2. If I multiply here by 2 over 2, this will cancel this, this will multiply by this. So that will be what? 16 over 3. So that's I wrote 16 over 3 there with the negative sign kept as it is. So that will be the final solution to this one. So now we come to 6. On 6, we're given the integral of the 4th root of x to the 3rd minus 1 over the cube root of x dx. These brackets, they're not writing them because they're bold, so you should also write them. So you can see that every problem that has, it either has minus in between those terms, I put those brackets there. So me and the guide were not crazy, right? You should make sure that you write them also. You should write those brackets. So now this will be the integral of x 3 over 4 minus x minus 1 over 3 dx. So the one that is inside is always the numerator. The one that is outside is always the denominator. You see, right? And then that is always the case. And then here I can just distribute. This is simple. Then you can just be checking what is that exponent plus 1. I'm integrating instead of distributing. 3 over 4 plus 1 over 3 over 4 plus 1. So this will be 7 over 4, 7 over 4 minus x, and this will be minus 2 over 3, minus 2 over 3 plus c. And this would be 4x 7 over 4 over 7 plus this will be 3x minus 2 over 3 over 2 plus c. See, right? Then that will be the solution. Now, if I want, I can take this x to the denominator because there is a minus on the exponent. So I could take that to the denominator. So now we come to number 7. This is the integral of 1 over the 5th root of x plus 1 squared dx. Now this would be then we just multiply them through. So this will just be x to the minus 1 over 5 times x to the minus 1 over 5, right? And then plus x to the minus 1 over 5 plus x to the minus 1 over 5. And then we have plus 1. Put those brackets, dx. Then this would be, because this is the same thing as x to the minus 1 over 5. You see, right? And then this would be the integral. If I check, I keep the base at the exponents, then that will be minus 2 over 5 plus 2x to the minus 1 over 5 plus 1 dx. Now I can distribute this. So this would be and then this would be 2x then you can just be checking what are these. So the integral of 1 will just be x, and then this would be x, then that is 5, 3 over 5 over 3 over 5 plus 2 x, this will just be 4 over 5, 4 over 5 plus x plus c. This will just be 5 x 3 over 5 over 3 plus 5 times 2 is 10 x 4 over 5 over 4 plus x plus c. Then that will be the solution to number 7. And then now if we come to number 8, on 8 we see that we have the integral of 6 e to the u minus u to the 4 cubic root of u plus 5 du. And then from here, now I can compute this. And then this will be the integral of 6e to the u du minus the integral of u to the 4 times u to the 1 over 3 du plus the integral of 5 du. And this will be equal to 6. This will remain the same. Every time you integrate e to the something, it remains the same. E to the u actually, or e to the x, as long as it doesn't have any constant there or negative. So this would be integral of u. So if I add these questions, what would I get? 4 times 3 is 12, 12 that is 11, 11 over 3 du plus 5u. So I won't add c because I'm not done integrating everything, you see, right? I was just integrating these one by one. So I did this for a reason. So you are allowed to integrate these one by one. Then when you are done integrating everything, you can now you add c. Now the integrals are gone, I can add c. And then this will be 6 e to the u minus u to the, so 3 plus 11 is 14 over 3 over 14 over 3 plus 5u plus c. This would be 6 e to the u minus 3u 14 over 3 over 14 plus 5u plus c. So we get that for number 8. Now, you know, right? I don't write everything. So I'm gonna leave number 9 to you. So what I can do, I don't know who's volunteering to confirm if our solutions are correct. You just take this, you go to Photomath, you scan this, scan all of them up until number 8. Then you check if our solutions are correct. All right, you can do that. I think I'm writing maths tomorrow, so after here I have to rest. So I don't think I'll have time to look at this. So try this. You know, I always leave something for you to try. Try this. Try this. So we managed to write 1 up until 8. You can try number 9. Then it means that when we come back again, we need to look at chapter 10, methods of integration. So there's no time, right? If you haven't started studying L'Hopital, you don't have time. In class, you're gonna be covering this part. Don't forget, you don't do exercises in class. You're gonna be covering that part, covering your substitution. If you get lost on your substitution, there's no time. We need to move up until by parts. After your substitution is by parts, you won't have time to process what's happening. So this is by parts. I think it started somewhere here. I think, let me see. Yeah, by parts, integration by parts. And after by parts, it's by fraction. Trust me, you won't have time to be processing things. Next thing, you'll be failing because you're not prioritizing your studies. So you should make sure you study. If you're not done with L'Hopital rule by now, I'm judging you. Judge yourself also. You're not serious. In other words, if you're not serious, it means that you're not ready for promotion, right, to the next grade. So you should make sure that you pull up your socks. Yeah, so we can end our session here. If you have any question, you can ask. Hussein, can I please do what? Let me stop.
Please share link.